makers! Today I want to talk to you about a car I just made using a custom circuit and my circuit Scribe components.
This little car we made can drive forwards and backwards. We can also vary the speed.
In my custom circuit, I am using a potentiometer to control the base of my transistor. The current then flows out of my transistor and into my DPDT switch. And because of the way the DPDT switch works, I can change the direction of that current to control the direction of my motors. So that's how the electronics work in my car. Let me show you how I built it. Here's the initial schematic I drew for my car. As you can see, there are some corrections and stuff that have happened up here because that's what happens when you prototype. You always change things. My battery module goes here on the end. Then we have our potentiometer next to the battery and our transistor. Then our DPDT switch gets stuck in this configuration here. And initially I had this set up for one motor so that I could change the direction of my motor and the speed of my motor. But of course, with a car, you need two motors, so had to adjust it like that. This was my initial circuit that I drew for testing, and everything worked great except that to make the paper easier to bend, I used an X-Acto knife and I scored it. And when I scored it, I actually broke that trace right there. So make sure that when you score it on the back side and then bend it so that your paper is still continuous and it doesn't break your circuit.
I needed my entire steel sheet for the top of the car. I used an X-Acto knife to score the bend lines to make it easier to fold. I then drew my circuit based on my prototype schematic, making sure to put my components close together to minimize resistance. After double-checking the spacing of my components, I prepared the wheels. Each wheel was made from two 2-inch circles of foam core board. For the tread, and to connect the two pieces together, I used a rubber band. I placed the motors to make them even with each other, and close enough to the edge of the paper so that the bottom of the car wouldn't drag. When drawing my traces, I made sure they were nice and thick to help minimize resistance in the circuit. As we have realized from our lessons, motors require more current than LEDs. On the underside of my car, I used some mini steel sheets to keep the sides perpendicular and to connect the motors. To hold everything together and to keep the sides from collapsing, I used some small neodymium magnets. To keep the back end from dragging, I folded up the paper and again attached it with some magnets. Testing my car with one battery, I have some speed control, but the motors were kind of struggling, so I added a second battery in parallel and achieved some good results. My DPDT switch controls the direction of my motors, and my potentiometer controls the speed.
Building this car was a lot of fun. There are some important parts to it that we should highlight. Number one, clearance. I can run my stencil along the car and at no point does any of the car touch the ground except for the treads on the wheels and this tail that we created. Next, our traces are nice and wide and as short as possible to minimize the resistance. I also added a second battery in parallel, which allowed more current to flow to the motors and allowed our motors to have more torque. The torque of a motor essentially amounts to its strength, and we need our wheels to have a good amount of strength so that it will drag the car and this paper clip across the table. I also moved my components as far forward as possible to get them over where the wheels are situated so that the center of mass of my car is as close to the wheels as possible. That did two things. Number one, it helps the wheels grip the table more because it pushes down on where the wheels are. And number two, it takes as much weight off the tail as possible and as much weight off that paper clip. On the bottom, you can see I've actually used two paper clips taped together to give me as much length as possible here. I've also used some tape to attach it to the base and to pull my sides in so that they don't flex out and make my car do the splits essentially. I've also got some magnets under here that hold my tiny steel sheet to my big steel sheet and keep the whole form factor of the car nice and square. This project wasn't one that came out of our inventor's notebook, but we got to use the concepts that we learned from our inventor's notebook to put it all together. If you decide to do something like that, I'd love to hear about it in the comments. As always, thanks to Scribe for sponsoring this series of educational videos. All of the components in this video are for sale on the Scribe website. You can use code BERBAWYMAKERS to get 15% off. While you're there, you can sign up for their live classes and get help if you're having difficulty with your pen or any of your other components. I'm Miss Berbawy. Thanks for sticking with us through this series of videos. For more maker content, check out the Berbawy Makers website. There's a link in the description. And keep an eye on our YouTube channel for more upcoming videos.